Welcome to Maths with EJD. In this video, I'll be talking about special cases in simplex method, focusing on infeasibility. Again, I keep telling you about the special cases in simplex method, special cases, and these cases actually include degeneracy, degeneracy, and that has been taken care of. That was the first video I made in this series. That should be the 19th video in the linear programming series. Then we talked about alternate optima, okay, also taken care of the video. Then the last video was about unboundedness, okay, taken care of. So this last one, this is actually the last video under simple special cases in simplex method. Of course, there's still a lot to do with simplex method, right? So in this video, I'm talking about infeasibility, okay? It's talking about special cases in simplex method. So let's go ahead and talk about that in feasibility. In feasibility. So we did something similar for graphical methods, and basically the condition is about the same. Once the constraints are once they are not consistent, once the constraints are not in line with themselves, then the solution would definitely be infeasible. So infeasibility, infeasibility occurs when there are no feasible solutions, when there are no feasible solutions that satisfy satisfy all constraints, that satisfy all constraints of an LP problem, an LP problem. So I mean, from the constraint alone, you can already judge. All right. So this typically, this typically this typically happens when the constraints contradict one another. Okay. Once the constraints contradict one another, then of course infeasibility is bound to occur. All right. So let's move on to see an example of this example. So imagine this problem. Um, so the objective function is to maximize. You want to maximize z equals x1 plus x2, and it is subject to x1 plus x2 less than or equal to 1. All right. And then another one is that x1 plus x2 is greater than or equal to 3. So, I mean, straight up, you can see already that the constraints are contradictory. I mean, if you plot this on a graph, right, there's going to be, in fact, we can try that out on um on Desmos, okay? Let's go Desmos and see what we can do with that. Desmos, okay. We can already see that these constraints will not work together. Um, all right. So you have x plus y. Of course, we can only use x plus y here. X plus y is less than or equal to 1. That's 1. Then you have x plus y, that's x1 plus x2, is now greater than or equal to 3. So you see there's a gap in between already. So we can already stop there. So there's no point even wasting time going forward to see what we can do with that. There's no point at all because the constraints already tell us all we need to know. Of course, usually x1 comma x2 is always greater than or equal to 0 for the non-negativity constraint. So I mean, with the constraint alone, you don't even worry yourself, because going for that, you already know you're not going to get any tangible results, right? So this first constraint requires the feasible region to lie. I mean, I've shown you in a graph, so there's no point telling more stories. So since the two constraints, so we can just go straight and talk about, so don't even worry yourself changing to standard form or anything. There's no point because the constraints, these two constraints are contradictory. They are contradictory. Once the constraints contradict, that's all. The constraints are contradictory. All right. So you can just go straight and talk about uh, the fact that the constraints are contradictory. So since the two constraints contradict each other, there is no common region. There's no common region where both constraints are true. So in fact, normally, right, before you even solve any linear programming problem, check the constraint to see if there are contradictions. So if you can quickly visualize it like I did with Desmos or any other tool you can use, that can help you. So you already know before you even start out that there are no feasible solutions. So just make your conclusion based on the constraints. So you can say hence the linear programming problem is infeasible. Is infeasible. Okay. It's already infeasible. So, I mean, there's no point. I mean, in the simplex method, we usually form a tableau based on the system of linear equations and proceed with pivoting operations to optimize the objective function. However, in this case, because the problem is infeasible, the simplex method would indicate that there are no feasible solutions. Typically, the simplex algorithm will flag infeasibility when there is no feasible starting basic solution. So, in this case, since the constraints are contradictory, the problem is infeasible and does not have a solution. So, overall, the problem has no solution. The problem has no solution. That's all. That's the meaning of infeasibility. And that's the end of that. Very easy. So that's like a point we need to note that whenever you have any linear programming problem, check the constraints. If you cannot visualize it, you can try to plot it manually or plot it on using something like Desmos or any other tool you can use. And from there, you can already see if there are no overlapping regions between the constraints, you just know that the problem is going to be infeasible and it has no solution. So if you have not subscribed to this channel, be sure to go ahead right away and do that. Hit the notification bell also so you can always get notified each time a new video is released. Then comment, let me know there's a problem you'd like me to solve or if there's a topic you'd like me to treat, let me know. If I have the power to do that, I'll definitely do it. Then, of course, like and share so that more people can have access to all this great learning. Watch out for the next video. I'm going to display in one video all the Python codes to show degeneracy, alternate optima, unboundedness, and infeasibility. I'm going to write Python code for all the same problems I have shown in the separate videos. I'm going to write put the Python code in one, just display all the codes in one video to explain, to verify all the things we have said, trying to do them manually. So watch out for that and be sure to see that so you can, I mean, that gives you a faster way of getting the solutions. Till then, keep optimizing. Bye.